Look at the wild Australian bearded dragon. Rough, earth-toned, perfectly adapted to vanish into the red desert sand. Now look at what sits in glass boxes today. Stark white, smooth as glass, glowing under a spotlight. If you walk into a modern reptile expo, you are stepping into an unregulated Wild West. Tables are flooded with animals carrying branded marketing tags like Inferno, Shadow, or Lemonfire. With zero market enforcement, any breeder can slap a premium label on an average animal. First-time buyers easily end up paying hundreds or even thousands of dollars for genetically compromised or entirely faked traits. To navigate this market safely, you have to read the lizard as a precisely stacked genetic blueprint. Breeders are quite literally stacking DNA layers on top of each other. Once you learn how to deconstruct that genetic stack, you strip away the marketing noise and make yourself immune to the scams. Layer 1 is the base canvas. Most vivid colors, like red, don't actually come from a single red gene. They are polygenic. Breeders select the reddest standard dragons, breed them, pick the reddest offspring, and repeat this across dozens of generations until they lock in a highly saturated line. But a base color is also the easiest thing to fake. Sellers frequently pass off standard animals as rare, high-value dark morphs using nothing but a cold room. As a basic survival mechanism, a bearded dragon rapidly floods its scales with dark pigment when its body temperature drops or when it gets stressed. This helps it absorb heat faster. There is one foolproof way to test if you're looking at a true dark genetic line or a cold lizard. Demand a photo taken after the animal has been sitting under a 100 to 110 degree basking lamp for 30 minutes. If the dark pigment fades under the heat, the genetics are fake. Layer 2 relies on recessive genes. For these traits to show up physically, the animal has to inherit a matching copy of the mutated gene from both of its parents. One of the most popular recessive traits is hypomelanism, or hypo. When stacked on top of a red line, this gene systematically deletes dark melanin speckling from the skin. Without that dark pigment competing for space, the underlying red explodes into a much brighter, cleaner hue. Sellers often claim an animal is hypo just because it's brightly colored. You verify it by checking the toes. A true hypo animal will always have completely clear, translucent nails with zero dark striping. Breeders then push the stack further by adding a second recessive trait, the translucent or trans gene. This genetic mutation physically alters how the scales scatter incoming light, giving the skin a semi-see-through, almost gummy appearance. A fully expressed transmorph is unmistakable. It develops solid black, alien-like eyes without a visible iris, and you can actually see the blue-black tint of its internal blood vessels through its belly. Combining these two recessive traits creates a striking visual leap, immediately driving the price into the high hundreds. The final layer involves co-dominant genes. These show a physical effect with just a single copy. The most prominent is the leatherback morph, which acts as a physical sculptor, deleting the rough, jagged spikes along the dragon's back. This structural change creates a massive optical advantage. Jagged scales naturally scatter light, which mutes the colors underneath. By flattening the scale surface, light reflects directly back, making the colors 30% more vivid. So breeders stack the sequence, starting with a red line, stripping melanin with hypo, altering light diffusion with trans, and smoothing the canvas with leatherback. The result of that specific genetic stack is a jewel-toned, smooth-backed dragon with solid black eyes. It's an engineered masterpiece, and it regularly commands prices north of $1,400 on the open market. Pushing biological limits to create high-value art creates serious friction. When breeders prioritize striking aesthetics over everything else, the animals absorb the cost. Look closely at this Punnett square. Because leatherback is a co-dominant trait, breeding two of them together forces a genetic extreme. 25% of the offspring will inherit two copies of the mutant gene, resulting in a variant known as a Silkback. A Silkback is born completely naked. The double genetic mutation strips away every single protective scale on the animal's body. They possess paper-thin, extremely fragile skin. They suffer from chronic tearing during normal shedding cycles, and they face severe hypersensitivity to the intense ultraviolet light they need to survive. Breeding them crosses a hard line from selective artistry into cruelty. Even the safer, ethical morphs are not a simple visual upgrade. Modified DNA demands modified husbandry. You are taking on biological engineering that requires direct environmental compensation. Leatherbacks require specialized shedding aids, lacking the rough friction points to pull off old skin. Translucent morphs need reduced UVB exposure to prevent burns. And heavy dark morphs demand hyper-precise temperature controllers because their dark pigment absorbs radiant heat incredibly fast, risking dangerous overheating. Decoding these traits is the only reliable way to protect your wallet from a market saturated with misleading labels and fake genetics. More importantly, knowing exactly what is coded into your animal's DNA is the only way to provide it with a safe life. Mastering the science of inheritance is the absolute prerequisite for keeping a human-engineered species.